All right, here we go. No calculator number one. Apologize for my voice. A little bit too much yelling at the wrestling meet last night, but hopefully it'll still be okay. All right, number one, Tony spends $80 per month on public transportation. A 10-ride pass costs $12.50. Single ride costs $1.50. If G, so G represents 10-ride passes. So we're basically looking at it's $12.50 times every 10-ride pass. And then we're going to add to that, looks like he buys, T represents, so T is the single ride passes, which they told us that was $1.50. So we have $1.50 times the single ride passes. And that needs to be, it looks like he spends $80 per month. So that needs to come out to be exactly 80. So correct answer here is D. All right, moving right along. Down to the next one, number 2. So it looks like we have another model. The first one we actually had to construct our own model. This next one's what's called interpreting models. They give me one, I got to interpret what the letters mean, the numbers mean. T represents the total take-home pay. So we have the pay is $1,000 plus 18 times, it looks like H represents the hours. So for some reason we get $1,000 plus $18 per hour. So a way to read that is 18 per hour, which is actually the slope. So the one-time fee, it looks like the $1,000 represented the sign-on bonus. So whenever you see this number here by itself, that's usually some sort of one-time fee, all right, or an activation fee or a starting amount. But thinking about the graph of this thing, we have slopes and we have intercepts. So this one-time fee would represent the y-intercept, and this 18 right here would represent the slope or the rate of change. So what do we got? It says if Brittany's take-home pay was $1,576, so we know T, the take-home pay was $1,576. We have a $1,000 signing bonus plus $18 per hour. How many hours? So ultimately, we need to solve for H. So we're going to take away the signing bonus. You know, if that was her paycheck. Take away the signing bonus. That leaves $576 was broken up into her hourly pay, which was $18 an hour. Divide. This is the no calculator, so you have to be able to kind of get this one without using a calculator. So hopefully you can do that. But the correct answer there is 32. Now, if you need a little long division refresher, you could do it this way. 18 goes into 57 3 times, which would be 54. And then subtract, and you get 3, bring down the 6. 18 goes into 36 2 times for your final answer there. Now, another way you could do it if your algebra is pretty weak is you could kind of scratch all that, and you could basically just start plugging in answers here for T until you ended up getting 1576. So that's just kind of another option there. All right, scrolling down to number 3. Looks like we have an inequality, some sort of a story problem here. Clothing store is having a sale on shirts and pants. It looks like S is shirts, P is pants. During the sale, the cost of each shirt is $15. So $15 times every shirt, plus you have $25 times every pant. So just that right there, notice I can eliminate this part and this part because they have the wrong numbers on the wrong variables. So right now I'm down to a 50-50. Now I have to decide on these inequalities. And it says Jeff can spend, and here's the key word of the whole problem. He can spend at most. That means he can't go over 120. So that means whatever this stuff is right here, it's got to be smaller than or equal to 120. And that's the symbol that represents at most. So we're looking here. Correct answer is A. All right, moving on down. Number 4. So this one just looks like a straight up solve an algebra equation. so it shouldn't be too bad. So I see parentheses, so I'm going to distribute. I get negative 3x. A negative times a negative is a positive. On the left-hand side, I'm just going to copy it down. My strategy is I always attack the variables first. So I'm going to go after this minus 3x. I like to attack the smallest variable term and do the opposite to both sides. I do that because I like my x's to be positive. So I'm going to have a positive 1x plus 4. And then I subtract 4 from both sides. And we wind up with x equals 11. So the correct answer there is A. All right, heading on down. Number 5. A little bit more going on here. So it says, for the function f above, what is the value of f of negative 1? So basically, this function is any x. Whatever you have for x, you're basically just going to plug it in everywhere where you see an x. So since our x in this case is negative 1, I need to plug it in. So f of negative 1 is, instead of x to the third, it's negative 1 to the third. And then I have 3 times negative 1 squared minus 6 times negative 1 minus 1. So I just replaced all x's with negative 1. Now I got to be a little bit careful on my math. A negative times itself 3 times ends up being a negative. Plus, doing exponents first, a negative 1 times itself is positive 1. Positive 1 times 3 is 3. Over here I have a negative 6 times a negative 1. That's plus 6. And then I have this minus 1 at the back. So now cleaning all this up, a negative 1 plus 3, well that's 2. Added to 6. Do that part, it's 8. Take away the 1. Gives me a final answer of 7. So the correct answer there is C. All right, moving on down to number 6. Let's see what we have. So this one looks like a geometry problem here. I have 2 triangles that are similar. So usually when I have similar triangles, I'm going to be able to do some sort of proportion with side over side type of thing. So let's kind of see. I'm going to draw this thing out. So ABC and DEF are similar. Let's see who's bigger. If DE is twice the size of AB, so this kind of gives me a clue just on my drawing. So DE, the side DE is twice as big as AB. So ABC is smaller. So let's just kind of draw this triangle. We're going to call it A, B, C. And then I'm going to do a big fella. And I'm going to try to draw him twice as big, just so it kind of looks how it's supposed to. And I'm going to keep the letters in the same order because they said that A, B, and D, E were corresponding. D, E, F. And A, B, and D, E are corresponding sides. So that means that this side and this side should be in proportion with each other because they're similar. And it's a factor of 2. So whatever AB is, I don't know what AB is, DE is going to be double that big. So it's either like 5 and 10 or 4 and 8. It says the perimeter of ABC is 20. So the perimeter is when I add up all the sides. So the perimeter up here is 20. Well, if you double every side and then you add them up, this perimeter is going to be 40. So the correct answer here is B. And even if you weren't sure, let's kind of get rid of this x and 2x. You could put your own numbers in here. So let's say I want to make a perimeter of 20. Maybe I call this 5, and I call this 7, that'd be 12, and call this guy 8. Well, if everything is twice as big, you're going to have down here a 10, a 14, and a 16. So that would just be another way to get you to 40. But whatever the sides do, the perimeter does. All right, moving right along, let's go down to number 7. So looks like we have some sort of population problem. There were no jackrabbits in Australia before 1788. All of a sudden, they introduced 24 jackrabbits. All right, so 24 is my starting amount. Okay, or a lot of times they use the keyword the initial amount. By 1920, the population had reached 10 billion. If the population had grown exponentially, that's very important here, this would correspond to a 16.2% increase. All right, which of the following could find it t years? So let me just kind of show you. All exponential problems follow this pattern. This is a good thing that you need to know. You always have the starting amount, or the initial amount, however you want to phrase it. You have the starting amount, and then if you're doing growth, all right, or increase, you're going to do 1 plus the percentage, all right? And then you're going to have time as an exponent. So that's kind of the pattern for all growth problems. So if we look at this problem, we start with 24 rabbits. Now, even if you can just get that part, all right, you're going to be in pretty good shape. And then we do our growth part. So we have a 1 plus 16.2% as a decimal is 0.162. You move the decimal 2 to the left. So that's a 1.162. That shows 16% increase. And then we have our time. So looking down here, it looks like the correct answer is C. So some of these other ones look close. Be careful here because the 24 should not be raised to the t power, so that's the mistake here. This formula is doubling. That means you take 24 and you double it, and then the exponent's all jacked up. And then this one just has these two reversed, where you're doing 24 to the t power as opposed to the growth factor to the t power. So the one thing kids struggle with oftentimes is adding the 1. You know, a lot of times knowing to add the 1 plus your percentage is something that people screw up. All right, moving right along. Number 8. So this looks like something that I would call manipulating expressions. So we don't have an equation. There's no equal sign. We're not solving. But we are manipulating this expression to turn it into one that looks like somebody else. So if you notice, it says, what is equivalent to the sum? Well, that means add. So I'm adding 3x to the 4th, 2x to the 3rd. I'm adding that expression plus 4x to the 3rd, or 4th, my bad. And then 7x to the 3rd. So we're just adding these two things together. So we need to gather like terms. 3x to the 4th plus 4x to the 4th is 7x to the 4th. Do not change the exponent there. We're just combining like terms. Positive 2x to the 3rd, positive 7x to the 3rd. That's positive 9x to the 3rd. And which looks like correct answer of D. All right. Looking pretty good. Number 9. Looks like we have some function notation going on here. So number 9, f is defined as f of x equals f squared. We have a g function. Which of the following translations? So translation just means we're going to shift the graph up, down, left, right, make it fatter, skinnier. How are we going to move f so that it results in g? So basically we want to know, how do you get from x squared to x squared plus 3? All right. So if you graph both of these, if you graph y equals x squared, it's a parabola that looks like this. And basically when you add a constant to the back, that's going to shift it up 3 units. If it was minus 3, it'd go down. So my new graph is going to move up 1, 2, 3, and would look something like this. So there's the g function. The black is the f function. So it looks like we did 3 units up. Correct answer, B. All right, next one, number 10. Another geometry problem here. So it says, be careful right here. Figure not drawn to scale. That means they usually try to trick you with the picture, so be careful. In the figure above, segments AE and BD are parallel. So AE and BD are parallel. If angle BDC, so you got to know where that is, BDC. So that means you start at B, go to D, finish at C. So we're talking about this angle right in here. BDC measures 58 degrees. And angle ACE, so from A to C to E, so it's that top vertex angle there, is 62. What is the measure of angle CAE? Well, CAE, the angle we want, is right here. So that's the answer to the problem. Now, what we need to understand is because of the parallel lines, when you have parallel lines and a transversal cutting down, basically we have this angle needs to equal this angle, all right? And then this one needs to equal this one, and they're all corresponding angles. They're in the same position. So we can translate or slide this 58 down to this corner because they're both making the same angle with the same line. So now I'm just going to use the fact that this big triangle should add up to 180. And right now I have two of the three angles. So 58 plus 62 is 120. And if all triangles have to add up to 180, we subtract what we have, and that means we need 60 degrees left. So the correct answer, B. Number 11. So number 11 says an oceanographer uses the equation S equals 3/2 times P to model speed of an ocean wave. P is the period of the wave. Which of the following represents the period? So this is important. The period, this phrase you see on every single SAT test, in terms of, all right? So that means we're solving for a different variable. We want to have P in terms of, and then something to do with S over here. So basically, moral of the story is solve for P. Well, to get P by itself, I'm going to get rid of 3/2 by multiplying by the reciprocal. So I'm going to multiply this side by the flip, by 2/3. Now, why I did that is because I end up with 6/6, which is just 1P. And I cleared that fraction out. So now if I multiply the right by 2/3, I have to multiply the left by 2/3. And this becomes a pretty simple problem. I've now solved it in terms of P. So correct answer is A. All right. Scrolling down. Boom, boom, boom. Number 12. See what we got going on here. So which of the line could be an equation for the graph of the line above? Well, look at my units. That's the first thing. They're trying to screw you up a little bit here. Notice this bottom scale is going 2, 4, 6, 8, 10, 12. All right, so we went over 12 there. And then this axis is 1, 2, 3, 4. All right, and that's another point. So basically we have 2 points if you want to look at it that way. We have a point 0,4 that lives on the graph, and then we have a point 12, 0 that lives on the graph. So I could use that. I think an easier way is to kind of look at the key features. Right here is the y-intercept. All right, so when you think about y equals mx plus b, remember this number right here should represent the y-intercept. So I know the equation ends in +4. So that eliminates A, and that eliminates D. Right now I got it down to a 50-50, which is awesome. I mean, we just greatly increased our chances. Now we need to see that the line is coming down, so it has a negative slope. Remember, M represents the slope. And the slope is always the change in Y over the change in X. A lot of kids like to say the rise and the run, but I like to think about change in Y and change in X. This line is changing. We went down by 4, and we went over by 12. So we have a negative 4/12 slope, or a negative 1/3. Every time you go down 1 over 3, down 1 over 3, down 1 over 3, down 1 over 3. All right? So, correct answer, C. All right. What do we got next? All right, number 13. Geometry problem here. Says, note, figure not drawn to scale. So again, be careful. It might not be what it looks like. So triangle FGH is inscribed. That just means that its vertices are perfectly right here on the corners. Arc FG is congruent to arc GH. The measure of G is 30. Find the measure of H. So our ultimate goal is find the measure of this angle right here. All right. Well, let me kind of just give you an in general idea. So if you have a circle and you have an angle that is inscribed on a circle, let's just kind of draw an angle from right here, and let's say it goes from there to there. All right. Well, there's a theorem that basically says an inscribed angle, let's say that this is 40 degrees right here. When you travel out and then you look at the arc that was trapped or intercepted between the angle, this should be exactly double. It should be 2 times. So in general, whatever the angle is, you double the arc. All right. So the angle is double the arc. And one thing you should also know is that all the arcs around a circle should equal 360 degrees. So when I'm kind of looking at this problem, the first thing that they give me, the first kind of clue that we have, is that we know that FG is congruent, which means equal to GH. So we know that FG is equal to GH. So I'm going to put that on there. Now, that also means, because look who created those. This arc right over here was created by angle F. So we know that angle F is going to actually come out to be the exact same as angle H, because angle H created the same size arc. Now our clue, what they give me that really helps me out here, is they do tell me what the angle of G is. So angle G is 30 degrees. And angle G intercepts this big piece. This is trapped by angle G. So I need to double that. So if G is 30, the arc out here, FH, is 60. Now, because that's 60, we need 360 in a whole circle. So if I take away 60, that leaves me with 300 degrees left. So if there's 300 degrees left, and these two arcs are the same, 300 divided by 2 is 150 and 150. All right? But we're still not in the clear because we need to get back to find the measure of H. So we need to work backwards and shrink it and cut it in half. So we have 75 and 75. Now our triangles adds up to 180. Our arcs are twice of what our angles are. The arcs are all 360. We're in great shape. Correct answer there, C. All right, number 14. This one looks like it's getting a little bit tougher. Which of the following is equal to that expression? It's kind of small, so I'm going to rewrite it here. The fourth root of x squared plus 8x plus 16. And one thing to know about fourth roots is the fourth root is really saying the same. This is the law of exponents. It's really saying that x squared plus 8x plus 16. Instead of putting the fourth root, I can raise it to the 1/4 power. So that's something you need to know. A square root is the same as something. So square root of x is the same thing as x to the 1/2. The third root of x is x to the 1/3. Put a 2 there. The fourth root of x is x to the 1/4, and so on and so forth. Normally we don't put a 2 there, but it's kind of understood. So just know that number is the bottom of the fraction. Well, I'm still not any closer. I don't really see any 8x's or 16's over here in my answers. So, but when I look at this, I think I can factor it. You know, this thing can be factored into x plus 4 times x plus 4. Okay? And all of that is raised to the 1/4 power. And then if I shorten this, x plus 4 times itself can just be written as x plus 4 squared, all to the 1/4 power. And then a rule of exponents, when you take a power to a power, you're raising a power to a power, you multiply. So this is really x plus 4 to the 2 times 1/4 power. And 2 times 1/4 is a half. So x plus 4, clean that up to the 1/2 power. Correct answer here, D. So a little bit tougher. That's in Algebra 2, laws of exponents. if you need to brush up on that, fraction exponents, you might want to go back and take a peek at it. All right. So number 15 says ax plus by equals b. In the equation above, a and b are constants. This is a pretty important clue right here. It says that a is smaller than b, and they're both bigger than 0. So right there, you know that a has to be less than b because of this little expression. So which of the line could be the graph? Well, this is written in standard form. Ax plus by equals c. I'm much better in slope-intercept form. So what I'm going to try to do for slope-intercept form is I'm going to solve for y, or I'm going to get y by itself. So the first thing I'm going to do is I'm going to minus ax from both sides. And I end up with by equals negative ax plus c. And then I'm going to divide everybody by b. Divide everybody by b. So you get y equals negative a over b x plus c over b. And actually, looks like I was so used to standard form, I wrote c there instead of b. So I'm going to go back and just clean this up a little bit. It's not worth redoing everything. And b divided by b can be simplified, which is really nice, to just 1. All right. So now I got some important information here. I now can see that my y-intercept better cross at positive 1. So right away, that eliminates a because this crosses, oh, I guess that is 1. It looked like it was 2 blocks up, but they have the little 1 there. So check that. It does cross at 1. So you're still okay. C crosses at 1. B does not. B crosses down here. So B's out. D still crosses at 1. So right now I could only eliminate one answer based on the y-intercept. So now we got to use the clue of the slope. So this is my slope. Since it's negative, I know my line is going down to the right. All of these lines are negative. They're going down to the right. But here's where this clue about a being less than b. If a is less than b, I know that I'm going to go down less than what I go to the right. So for instance, let's just pick a couple numbers. Since we know a is less than b, let's just pretend a is 1 and b is 2. All right, because 1's less than 2. If I put that in here, a slope of negative 1/2 means I'm going to go down 1 over 2. All right, that would give me the correct slope of negative 1/2. So I know I'm going down less than I am to the right. Well, a goes down the exact same amount. So that one it can't be. C's looking pretty good. I go down and then over twice as far. D, I'm going down double and over less. So that eliminates D. So the correct answer here is C. That was a tougher problem, pretty abstract. All right, number 16. I'll blow this back up a little bit since there's not a whole lot on this one. So what value of x satisfies the equation above? This one is going to be over before it even starts. This is just solving an equation. Combine like terms. 2x equals 9. Divide both sides by 2. Now, when you grid this in, you can grid it in a couple ways. You could bubble in the 9, the slash mark, and the 2. 9/2. Be totally fine. They'd accept it. You could, in your head, know that 9 divided by 2 comes out to be 4.5. You could grid those in. What you cannot do is you could not change it to 4.5. Even though it is 4.5, there's no way to bubble that, because when you bubble it in, you're going to bubble 4, you're going to bubble the 1, you're going to bubble the slash, and you're going to bubble the 2. And what it thinks you want, it thinks you want 41/2. So you're not allowed to bubble in mixed numbers on the SAT. So leave it as improper or leave it as a decimal. Just a little tip there on bubbling. All right, number 17. Getting closer here to the end. What is the solution to the equation above? A couple different ways I could tackle this. It looks like they're wanting us to waste a lot of time and set up a proportion, which I would not do it this way, but I'm going to just kind of start it and then show you why it's not as good. So when you leave the left side as it is, and the right side, since it's just x, you could put it over 1. And then some people may want to cross multiply here. The problem is you're going to start getting into quadratics. I'm not going to keep going, but you're going to get 11x minus 33, because when you times it by 1, you just get that. When you come the other way, you're going to get x squared minus 3x. And now you got a quadratic on your hand, which is a little bit hairier. I'm going to try to factor in this top piece. I see I can pull an 11 out. And when I factor an 11 out, it's kind of like reverse distributive property. I'm going to get 11 times x minus 3 all over x minus 3. And that equals x. And now since I have an x minus 3 on top and bottom, they can cancel out. And I simply just end up with x equals 11. That is way easier than over here. If you were to finish this problem, you'd want to set one side equal to 0. So I'd want to minus the 11x. And I'd want to add this 33. And then this all goes away and I'm going to have 0 equals, that'd be a negative 14x plus 33. Now you'd have to factor this. So I guess I will finish it. Two numbers that times together to make 33, add together to make negative 14. So that'd be x minus 11 and x minus 3. If you FOIL that, you will get what's above. And then zero product property. If this times this equals 0, one of these expressions are 0. He's 0 when x is 11. He's 0 when x is 3. So it says, what is the solution to the equation above? The problem is 3 does not work because when you put 3 in here, you divide it by 0. And that's not allowed. You're not allowed to divide by 0. So that's why the correct answer is 11. Much easier if you do it this way. All right. Keep on plugging. Number 18, systems of equations. I knew this was coming up. There's always systems of equations on here. If xy is a solution to the system, what is the value of 100x plus 40y? So ultimate goal here is find x, find y, then do the math to figure out the answer. All right, so don't let that part distract you. Right now to me, this is set up perfectly. See how I got my x's lined up, my y's lined up, my equals, and then my constants or my numbers? This is set up perfectly for a system of equations using elimination. So in order to do elimination, basically what I need is I need to get my coefficients or my numbers in front of the x's and y's. Somebody I got to get matched up. Now, I don't think I can really multiply 2 by something to match it up with 3. I'd have to use decimals, which I don't want to do. But I think I can get my y's to match up. I'm going to multiply this entire row by 3. So let's leave our top row the same. And let's multiply the entire bottom row by 3, which is going to be 9x minus 3y equals 90. Don't forget to do that last number. And now I see that if I'm going to eliminate these y's, I have a minus 3y and a plus 3y. I'm going to add these two rows together. So 2 plus 9 is 11x's. A positive 3y and a negative 3y cancel each other or eliminate. And then 31 plus 90 is 121. Divide both sides by 11. And 121 divided by 11 is 11. All right. So I now know what x is. So part of my answer here is going to be 100 times 11 plus 40. I got to now get y. Well, once I found 11, I can substitute back into one of the two original equations. So maybe I'll use this one right here. I'm going to go 3 times x, which I now know, minus y is 30. 33, take away what is 30. That means that y equals 3. And when I plug the 3 in here, let's try to get the final answer. So this is 1100 plus 120, which is 1,220. Sounds like a scary answer, like it's a little bit big, but should be the right one. All right, number 19. Should keep getting a little bit tougher in theory. So t is going to be a positive number. That's all this means is don't use a negative, use a positive. 3t in parentheses squared minus 5 times 3t minus 14 equals 0. So if you're looking this up or you're trying to find another video to help you with this skill, you're solving quadratics. And normally when you solve quadratics, there's different methods. I always try to factor first. Sometimes you can do what's called complete the square. Sometimes you can just take the square root, not very often, or you can use the dreaded quadratic formula. I think on this one we're going to be able to factor by looking at it, but let's check it out. Here's an advanced skill. If you notice what's in parentheses here and here, that's the same thing. So we can simplify this. Let's just let x be 3t. All right, so I'm going to rewrite this expression as x squared minus 5x minus 14 equals 0. And so if I do that, this is actually very easy to factor. I need to find two numbers that multiply to make negative 14. So this is your multiply term. So think about how I can make negative 14. Well, I could do negative 1, positive 14. I could do positive 1, negative 14. I could do positive 2, negative 7, or negative 2, positive 7. Those are the only combinations to make negative 14. Now, they need to add to make 5x. So running through these, which one of these could add to make negative 5? Looks like this combination right here. If you add that up, you're going to get negative 5. So I need the combination x plus 2 and x minus 7. Now, those are what are called factors. So the zeros or the solutions are, you know, if something times something equals 0, either this expression has to be 0, or this expression has to be 0. So we solve these. So x is either negative 2 or x equals positive 7. I now need to come back down and I need to replace x because remember x is 3t. So when is 3t equal to negative 2? And when is 3t equal to 7? Well, divide this side by 3 and I got t equals negative 2/3. That cannot be the answer. For one, on any short answer question or free response, there's no negative to grid in. So that's why they said t had to be positive. So even though this is kind of correct, it won't work for this test. It's going to be this answer. Divide both sides by 3, and you're going to get t equals 7/3. So 7/3 is going to be the correct answer. Moving on down to number 20. Let's get rid of this. All right, looks like we have a function. So h of x is x to the third plus ax squared plus bx plus c. A, b, and c are integers. So remember what an integer is. That is just a positive or a negative whole number. So no fractions or decimals. If the zeros of a function, so this is an important concept. The zeros of a function are negative 5, 6, and 7. All right? Well, if those are our zeros, we know that we have factors that are the opposites of those. It's kind of similar to what we did in the last problem. We know we have a factor of x plus 5 because negative 5 makes that 0. We know we have a factor of x minus 6 because 6 makes that one 0. And then we know we have a factor of x minus 7. Now, so since we had zeros, we could work backwards to get factors, and now we can multiply these three things together to try to come up with the actual equation. So let's just first deal with these two. So I'm going to just kind of FOIL these two. So I'm going to do x squared minus 6x positive 5x negative 30. And when we clean that up, I can put these two middle terms together, and I'll get x squared minus 1x minus 30. All right, so that's the answer from this portion. Now we need to multiply that by the last piece. So this is going to be an even bigger, it's not really FOIL anymore, but we're just distributing a bunch of times. X squared times x is x cubed. X squared times a negative 7 is a negative 7x squared. Now we do the minus x. Minus x times x is minus x squared. Minus x times a minus 7, positive 7x. And now the negative 30 gets his turn. Negative 30x. Positive 210, looks like. And now we got some housekeeping to do. Now we got x to the third. Minus 7 and minus 1, that's minus 8x squared. And then we have plus 7x minus 30x. That's a negative 23x. And then we have a plus 210. And ultimate goal, I guess I should have cheated and looked at that in the beginning. Might have been faster. What is the value of c? So they just want to know what's the very last term when it's all multiplied out. So I did some wasted work there. Correct answer is positive 210. Early on, let me just kind of show you why I wasted time. This expression right here, when I had x squared minus x minus 30, and I was multiplying that by x minus 7, if I would have read ahead and saw what they wanted, I know that the last term is always just created by the last times the last. And I could have just skipped all the other stuff, and all of this was just kind of a waste of time, unfortunately. So sorry about that. Correct answer, 210. All right, we're done with the no calculator. Next video, we're going to be busting out the calculator portion. See you.